Hello, AP Physics 1. I figured I'd go through some of the review problems with you so that you could kind of go through it and learn as much as you can. I chose number 25 because it goes through a lot of the basic stuff that you should know. Number one, you should know how to do a free body diagram by now. We've done so many. Number two, you need to do a sum of forces, right? That seems pretty easy. And number three, look, no numbers in this one, which is what your AP exam will look like. So let's hop right into it. A student pulls a wooden box along a rough horizontal floor, rough meaning there's a friction. Look, there it is, at a constant speed. Constant speed means that means that the net forces is equal to zero, right? There's no net forces, no acceleration. By means of a force P, as shown to the right, which of the following must be true. So if we draw the free body diagram, usually, oh look, oh that should go down. Usually we write this as mg, but this problem does the notation w for weight. This is F normal, which they just designate with n. We usually write FF, but this is just friction. And then normally N and W would equal each other, and F and FA, like the force applied, would equal to each other if all the net forces are zero. But this time around, we have a pulling force that goes up like this, which means, well, we gotta do some component forces, right? So the component force going up is going to be P sine theta, right? Classic stuff. And that means the one going left and right, so this is equal to the P going up and down. So P of X, the horizontal component of that pulling force will be P cosine theta, right? That's just stuff that we've learned in class. This is just stuff that you got to just memorize. Good. Knowing all that, now we can do some sum of forces. Let's do the sum of forces up and down, the y-axis, up and down stuff. Up and down, we got two forces up. We got the normal force pulling it up, and we got the vertical component of that pulling force pulling it up. So that means the normal force and that P of y is equal to W. They should cancel out. Or if you wanted to do it all sum of forces, you would do it like P of, normal force and P of y minus W is equal to 0, right? Because they were in two different directions. But we know that those two need to cancel out. So looking at this, what must be bigger? Is the normal force bigger or is the weight bigger? Obviously the weight is bigger, right? Wait, no, the normal force plus that, yeah, the weight is bigger. So that means normal force added to something is going to equal to the weight. So the normal force must be smaller than the weight, right? I hope that makes sense. It's just a little bit of math sense. So that's one thing for us to look at. That means we could cancel this out and we could cancel that out. Is normal force going to be greater than? No, not so much. All right, it's less than. All right, let's look at F of, well, now we already know the answer, but let's prove it, and let's look at the horizontal. The horizontal sum of forces, we have friction, right, is going to need to equal to P cosine theta. P cosine theta. Okay, so P cosine theta is some sort of fraction, right? It's something real small. Like, for instance, cosine of 60 is equal to 1/2, right? We know that. So we know that P must be bigger than F. So P is greater than F. So now we have these two things. Oh, look, P is greater than F and N is less than W. The answer must be A. Okay, so I hope that helps. Just kind of reviewing some basic stuff. You got to know how to draw a free body diagram, do your sum of forces. Oh, know how to do your components, right? If it's up and down, you do sine. If it's left and right, you do cosine. Great. Thanks for watching. Bye-bye.